So a steady state solution, we'll chat about what the steady state is in just in a moment, but there's a few conditions we need to know first. So if the transition matrix has no zeros and the columns add up to 1, then the system will have a steady state. Now what a steady state solution is that over time the states will fall into an equilibrium, meaning that they will no longer change. So again, we'll take the rental car example where we've got an initial state of 50 cars in Bendigo, 40 cars in Colac, and the transition matrix that looks like this. We know that we can use this rule here to find the nth step. So let's do the first 15 steps, and I'm also going to include the 100th step. We did the first 2 already in an example before. I've skipped 4 to 16, but as you sort of go, you can see, all right, so it's getting closer to 30 and 60 around about. A bit closer still, and then even between 15 and 100, so that's 85 steps, it still doesn't drop below 30 or above 60. So it looks like eventually, as the weeks go on and on, we hit a steady state solution where there's 30 cars in Bendigo and 60 cars in Colac. Now, a strategy that I tend to use to find the steady state solution is I'll find S10 and see what that looks like. Then I'll find S100, then maybe 200, and sort of keep going until you start to see that the states are steady and they're no longer changing. So as a formal definition, if S0 is the initial state matrix and S is the steady state matrix, then we can find S by doing S is equal to T to the power of N multiplied by the initial state matrix as N tends towards infinity. So as N gets larger and larger and larger, we're going to get this steady state matrix. Now, we'll find the steady state with our example before with the working and broken machines. This time, we've already got the initial state matrix and the transition matrix. And what we're being asked is, in the long term, how many machines will be working and how many will be broken? And this bit, in the long term, that's the part of the question that actually tells you they're asking you to find the steady state solution. So in an exam or a SAC, you won't always get a question that says, find the steady state solution. They won't spell it out for you like that. But if you see something that says in the long term, that's what tells you you're looking for the steady state solution. So what I'm going to do, I think I've still got in my calculator, I've still got T and S0 defined from before, so that's helpful. So all I'm going to do is, let's start by finding T to the power of 10 times S0. Make sure you type it in properly. Let's try again. T to the power of 10 times S0. All right, so we've got 30.9 and 69.1. All right, so let's see if changing it to 100 steps will make a difference. All right, so we get to 25 and 74. Sorry, 75. That definitely changed, so we're not at the steady state solution yet. Let's try 200 steps. All right, we've got exactly 25 and 75. That's really close to what we had before. Just to triple check, let's try 300 steps. Yeah. So pretty much between 100 and 300 steps, the numbers didn't change. So our steady state solution tells us that 25 machines will be working and 75 machines will be broken in the long term. That's what the steady state solution has told us about this system. Now, the final part of Chapter 12C looks at matrix modeling using a recurrence relation similar to what we had before, but we've added on this plus B term at the end. So it's a little bit more complex. So once again, we're coming back to this rental car problem to help us understand. Let's say that the manager wanted to add one extra car to each location each week. So now the total number of cars in the system will be changing. So instead of using this recurrence relation rule, we need to use one that has this plus B on the end. And the B is going to be a column matrix. It's important to note that when you are using this type of recurrence relation, there is no easy rule for the nth step like we had with this one. There's no easy rule for the nth step. So in order to find S2, 3, 4, and so on, you need to actually go step by step. So you'll never be asked to really find a steady state solution, for example, because you're not able to easily check it by raising t to the power of something. It won't work here. So let's do an example. We've got the rental car company starts with 50 cars in Bendigo, 40 cars in Colac, and they get hired and returned according to this transition matrix. We already knew that. The manager adds one car to each location each week. What we want to do is find the recurrence relation and then find the number of cars at each location after 2 weeks. So because we're adding one car to each location, we're going to need to use this form. We've got the plus B at the end. So the column matrix B, what it does is it represents the number of cars being added to each location every week, which is 1. So B is going to be 1 for Bendigo and 1 for Colac. If the manager was only adding one car to Bendigo each week, that would be your B matrix. You'd have one extra car for Bendigo and no cars for Colac. Maybe every week the manager removes a car from Bendigo and adds it to Colac, like he drives it there himself. So maybe one car is removed from Bendigo and one car is added to Colac. That would be your B matrix. Bendigo goes down by 1, Colac goes up by 1. So that's just how the B matrix works. But for this case, it's 1 and 1. So this is our recurrence relation. What we need to do is just go step by step to find S2. So now to find, what we're trying to do is find S2 and go step by step. So first thing we need to do is we need to find S1. So we know S1 is going to be this transition matrix multiplied by the initial state matrix plus our B column matrix. So to start with, I'm just going to start by defining all these matrices that we need. It will save me time in the long run. So we've got that as our transition matrix. I've got, this is my initial matrix. I'll define it S0. And finally, that's B. All right, so now I'm ready to perform this calculation for S1. We've got our transition matrix multiplied by S0, and then I'm adding B to it. So I get 45 and 47. So that's my S1. Now to do the next step. So we've got S2 now will be the transition matrix multiplied by S1. So to do this in my calculator a little easier, I'm going to rewrite what I've got S1 here, and I'll define it as S1. So now I know that S2 is T multiplied by S1 plus B. And that gives me 41.7 and 52.3 on the bottom. So what that tells me is there's 42 cars in Bendigo and 52 cars in Colac. Now when you actually think about these numbers, that makes sense because 42 plus 52 is equal to 92. Now there's 2 weeks, sorry, not 92, 94. Now there's 2 weeks that have gone by, and because the manager has added 1 car to each location each week, so 2 cars a week are being added to this system, so it makes sense that after 2 weeks, it's gone from 90 to 94. So that makes sense.